Today we are going to discuss about a few concepts related to database design, because database design is one of the important parts in maintaining a database management system. So, let us quickly look at the agenda that we are going to discuss today. So, the first thing is related to database design. Why do we need to do database design? So, what is the necessity of doing it? The second thing is, what kind of architecture do we follow in designing a database? And this we will cover in the first session. The second session talks about various steps involved in database design, starting from requirement analysis, conceptual design, logical design, physical design, and security related aspects. And finally, we will conclude this session with an introduction to ER modeling, entity relationship modeling, which covers various kinds of entities, attributes, and relationships among those entities. So, let us get to the first session. So, the first session, before we begin the first session, let us have a quick recap of what we need to know to understand the database design. You must have, most of you might have already studied in your semester, in the initial sessions, what is data, what is database, and other things. So, data is a collection of known facts, and database is a collection of related data, data that is interrelated. And database management system is a set of application programs which is used to define, construct, manipulate, share the database. So, these are general definitions, because most of these things we use during the next three sessions. The next thing is the data model. So, data model is also a very important concept in database design. So, it is a collection of concepts that essentially describe the data types, the relationships among data, the constraints that we impose on data, and also the set of operations that we can perform on data. So, that those operations can be the basic operations or a certain kind of user defined operations. So, these are the things, these are like prerequisites to get to this session. Right. So, let us now start the design process. Essentially, any software product, the design of any software product is divided into two parts. It encompasses two different parallels. The first one is the database design, the second one is the application programs design. So, application programs design mainly database. So, these things are addressed as part of software engineering, starting from requirement analysis, different kinds of flow diagrams, sequence diagrams, etc. We do it as part of software engineering. The second, not the second part, another parallel. In fact, both these things go hand in hand. The second part is the database design. So, database design, what do we do here? It is a collection of steps. So, what we do in the application programs design, most of these things are similar to your database design. So, we discuss about the processes that design, develop, implement, and maintain the enterprise data. So, basically they talk about the data requirements. So, the database design addresses the design of your enterprise data. So, why is it needed essentially? Because of course, when we have software engineering, we can do application programs, alongside we can define your database also, but why do we need it as a separate step? So, the thing that we need to understand is, most of these days we have enterprise applications. When we say enterprise applications, they have a lot of data. It encompasses a wide gamut of data operated by different sets of users. So, if you take about a manufacturing company, they have customers, they have products, they have whole lot of supply chain operations, they have customer relationship management. So, they come across a lot of data. So, we need to maintain the data properly, so that we can perform all those operations quickly, effectively, efficiently. So, we need to provide the right data, we need to provide the data in the right way. So, to perform all these things, we need to have a proper design process in place. So, the design is, as described here, design is needed to meet the user's data requirements. Different users have different data requirements, and at the same time we need to provide high performance. So, when a user performs an activity, it has to be done in some stipulated time. It should not take too long. For example, you want to query your personal details, or you want to find the details of a customer. So, if it is taking too long, obviously the application performance goes down, and it leads to customer dissatisfaction. So, we need high performance. At the same time, we need data consistency also. You should not maintain data related to one particular object or one particular thing redundantly. Any kind of redundancy leads to data inconsistency. So, because you may update the data at one place, if you do not update it at another place, obviously you will have two different copies of the same data, which leads to a kind of ambiguity and obviously results in inconsistency. The fourth thing is reducing disk space, because as I said, we have whole lot of data related to different users, different entities, different kinds of operations. So, obviously, when you store such data, it consumes a lot of storage space. So, to reduce storage space, you need to properly design it, so that you maintain only the essential data and you maintain the data without any kind of redundancies. And last but not the least is the enabling easier maintenance. Obviously, if you maintain data properly, maintenance would be pretty easy. If you maintain too many copies and in different data storage devices, obviously it leads to difficult maintenance. So, if you properly design it, maintenance would be pretty easier. In fact, in database management, design is the heart and soul of your database management. So, this is the essential thing in database implementation. So, before we get to the database design activities and other related things, let us have a quick understanding of schema, because this is what we are going to use in the session in the architecture also. Schema is the description of the database. Basically, a schema is called the description of the database, which what do you mean by the description of the database? It talks about the record structure. So, how do you want to maintain? For example, you have a student record. So, what kind of data items it consists of, and what are the constraints on those data items, because there may be, if you take an employee record, there may be certain constraints on the employee record. The salary should not exceed so and so amount, the salary should not fall below certain amount. So, these are all data related constraints. So, your schema specifies all those things like the data types, the record structure, the constraints on the data, and also the possible operations that you can perform on the data. Actual data is stored in the schema of the database, but schema specifies what kind of data that you can store. So, in a sense, actual data changes frequently, because you keep updating records, you keep adding records, you keep deleting records, but the schema does not change so frequently. It's not that it does not change at all, it changes, but less frequently. So, less frequently as compared to your data. So, schema is succinctly specified, it's briefly specified using a schema diagram. Schema diagram does not contain all the details, but it gives the high level picture of your database, so that you can quickly understand what kind of data it stores, what are the relationships, what are the constraints, etc. So, because based on this schema itself, we will architect our database, because architecture is the prerequisite thing. As we know in the software engineering, architecture is the first thing before we design, because we need to follow certain design guidelines, certain architectural principles to design the database. So, in case of DBMS, there is an American National Standard Institute Spark architecture. It is the 3 schema architecture. So, we have 3 levels of schemas here. So, why do we go for the database approach? So, database, in fact, to maintain data, we have file systems, etc. But why do we go with the database approach? Based on CORD rules, we can briefly summarize them as: we need a catalog to store the database description, so that we can change it as and when we need it, and the data independence. So, we will discuss in the next slide what data independence is. And data abstraction. Data abstraction is hiding the implementation details, because as an end user, you really do not want to see how the data gets stored, how the data gets retrieved from your storage device. All you need to know is how to perform your operations. And support for multiple user views, because different users want to see different portions of data in different ways. So, obviously, you need to enable that. So, based on these objectives, ANSI, the American National Standard Institute, has come up with a 3 schema architecture. So, to achieve these objectives, they have come up with the 3 schema architecture. What are those schemas? One is the internal schema, conceptual schema, and external schema. Internal schema is the actual physical storage structure. So, it talks about how the data gets stored on your storage device. So, the second thing is the conceptual schema. Conceptually, it specifies what kind of data you are storing, what are the data types, what are the constraints, operations you can perform on the data. So, it specifies in a conceptual way. So, we will see what conceptual design is in the subsequent sessions. And finally, the external schema. So, what kind of data you want to see. So, it only gives a presentation of the portion of the database. So, what kind of data you want to see from which data items, and which data items you want to see. So, all those things are specified in the external schema. So, this is how it looks like the 3 schema architecture. So, you have the stored database, on top of it the internal schema, which describes the actions that the way data gets stored on your storage device. Secondly, you have at the second level you have the conceptual schema. In between these two you have the mapping. So, from the internal schema to conceptual schema you need a mapping, and at a higher level you have the external view, external schema, because that is what end users see. They do not really want to know what is happening underlying the database. So, for this you need to again have an external to conceptual to external data mappings. So, as part of the previous slide we talked about the data independence, because this is one of the important objects of your database design. So, what do we have here? So, you have two kinds of data independence, physical data independence and logical data independence. So, what do you mean by physical data independence? It is the ability to change the internal schema. So, you may change the way the data gets stored. It can be on any kind of hardware, you may change it, but it should not impact your conceptual schema. So, it is the ability to change the internal schema without having to make any changes on the conceptual schema. The second one is the logical data independence. It is the ability to change the conceptual schema without having to worry about the external schema. So, you want to change the second level, but it should not impact the external schema. So, database design is done with the main aim of enabling physical or logical independence. Of course, both these things, your physical data independence may be easier to achieve as compared to logical data independence, but still most of the database designs try to focus on achieving these things. So, now that we have understood the architecture, the 3 schema architecture, let us get to the database design. So, how do we map the architecture to the design? So, the 3 schema architecture and the three levels of data mappings and models. We have 3 levels of data models and 3 levels of mappings. So, these things enable us, or these things provide us the basis, provide us with the basis for database design. So, database design essentially focuses on producing a conceptual design, logical design and physical design. So, now that we have understood the prerequisites for database design, let us now get to the next topic. So, what are the steps involved in database design, the sequence of steps, and what do we perform there, and how do we perform these activities? And as you look at the references, for more details you can go to the 6th edition of Elmasri and Navate, Fundamentals of Database, and you can also browse the online for more information on this session. Now that we have understood the first session, let us get to the next session, which is the sequence of steps that we need to perform in the database design. In the previous session, we understood the 3 schema architecture, the foundation of database design. Now, let us look at the database design steps. So, what do we perform? What are the activities that we perform in the database design? So, let us get to the same slide which we have seen in the first presentation. So, the overview of application, any software product design. So, you have 2 different parallels, one is the database design and the application programs design. So, this is depicted in this diagram. So, you have any product, any service or any product design starts with requirement collection and analysis. So, this is the basic software engineering technique. So, that is what we do even in case of database design. So, we understand the user's requirements, end user's requirements, functional requirements, non-functional requirements, all those things in detail through different methods that we use, the facilitated application specification approach or quality function description approach, what we study in software engineering, or questionnaires, interviews, brainstorming. So, you perform a whole lot of activities to collect the end user requirements and you perform an analysis on those requirements. From there, you divide into 2 different parts. One is the functional requirements. So, functional requirements in the sense what kind of why are we building this software product? So what are its essential functionalities? The second thing is data requirements. So what kind of data flows? So your data flow diagrams may help in finding the database data requirements. The functional requirements anyways are addressed to your state diagrams, sequence diagrams, process flow diagrams, etc. So data, two different parallels. The second thing is, the second level, you perform the functional analysis for your functional requirements. So to understand, basically the purpose of functional analysis is to understand what kind of processes you need to design. As part of your data design, so you may perform a conceptual design. So this is database management system independent activities. These are database DBMS independent activities. So you can perform these activities even though you do not have any commercial DBMS available for the implementation of your project. At the third level, you have the application programs design for functional requirements. So what kind of programs you design, what kind of user interface you need to design. So all those things you specify in the application program design. Coming to the data requirements, you have the logical design. So this is where you implement your conceptual design using a commercial DBMS. That's why it's a DBMS specific approach. So it actually lies in between the DBMS independent activities and DBMS specific activities. And finally, you specify the physical design. So how the data gets stored on your storage device. And as part of your functional requirements, you specify how transactions are implemented, because transaction control is another session altogether. So let's not get too much detail into it. So transaction implementation, and also it talks about the application security and data security. So these are the essential steps juxtaposed. So application design vis-a-vis database design. So now, since we are talking about the database design, let's quickly look at the database development life cycle. So basically you have the requirement analysis. So you plan for your requirement analysis, you gather the requirements, you analyze those requirements, and you specify a high level database definition. So what kind of database that we are going to build. So in the previous sessions, you might have studied that database is a mini world. It's also known as universe of discourse, because it talks about only the specific part of the entire. For example, you take university. University is like a mini world which consists of a lot of objects, entities, etc. So that's what you specify in your database definition. The second step is the database design. So database design again is divided into three high level steps: conceptual, logical, and physical. And finally, the database implementation, because once you have your database in place, you need to load the data, because database design only addresses how the data gets stored, what are its properties, what are the constraints that you can specify, but it does not store the actual data. So your implementation will address it. So what do you do as part of implementation? You convert the data. If you have an existing system in a file based management system, or in some other mainframe system, or in some other data store. So you need to take the data, you need to convert it, you need to cleanse the data, you need to convert it, and again you need to load it. And finally, you need to test it. There are different levels of testing. You need to do performance testing, you need to do some functional testing to ensure that your database is properly designed and implemented. So these are the high level steps that we do as part of your database design development life cycle. Most of these steps are in line with your software development life cycle. There may be some changes with respect to your database implementation, but most of these things go hand in hand. So these are the high level steps that we perform in the database design. The first thing is requirement analysis, as discussed. The second thing is conceptual design, and then we do a logical database design, schema refinement, physical DB design, and application and security design. So let's look at all these steps with some kind of details. So the first thing is requirement analysis. It aims at understanding and documenting the data requirements. So the main purpose of this particular step is to understand and document the data requirements. So it does not talk about the functional requirements. It talks about what kind of data is coming in, what kind of data is coming out, going out, what are the requirements. So how do end users want to see the data? Are there any constraints on the data? So what kind of operations they want to perform? So it elucidates the key operations, the key transactions that need to be performed on data. The main focus is on data, not on the functionality. So, it also as I said, the main focus is on specifying how the data gets updated, how what kind of data gets retrieved, how much performance is needed, what is the volume of the data. Volumetrics is also another important thing, because if you do not consider it and you go with your database design, you may end up with a failure, because higher the volume, the lower the performance it becomes. So, obviously, you need to focus on the volumetrics of your data as well. The second step is the conceptual database design. So, this approach focuses on transforming your requirements. So, the first step is done. You have all the data requirements ready, all the operations to be performed. So, you have identified what kind of data comes in, what kind of data goes out. So, what kind of operations you need to perform, what are the constraints. So, the next thing is to map it to a conceptual design. So, you need to specify all those requirements in a conceptual way. You need to design them in a conceptual way. So, it is the description of the data that includes constraints and your operations. So, the important thing that you need to understand here is it does not include any kind of implementation details. It does not talk about how the data gets how the database gets implemented. So, it does not talk about it. It only talks about the high level description. So, it provides a kind of data abstraction. So, it does not focus on how the data will be stored, where it will be stored physically. It only concentrates on specifying the properties of data, their interrelations, and any kind of possible constraints that you can specify. So, to do this, you need to use a high level data model such as entity relationship model, which we are going to discuss in the next session, that is session 3. So, it uses a high level data model to describe your database conceptually. So, the next step in the database design is the logical database design. So, this is where the actual implementation starts. This is the DBMS specific component. So, this one is DBMS independent. You really do not know what kind of DBMS you are using. You can use an Oracle DBMS, you can use a Microsoft SQL server, or you can use MySQL, you can use PostgreSQL. It does not really matter at this stage. What matters is to understand your data requirements and design them properly, conceptually. What are the properties of your data, what are the constraints, what are the operations that you can perform. So, at a high level, you specify this thing. So, this is DBMS independent activity, whereas this one is a DBMS dependent activity, because this is the step where you transform your conceptual design into a logical design. It's nothing but performing the actual implementation of the database. So, it enables the data to be stored independent of physical considerations. Again, this step also, though it implements your database using a commercial DBMS, it neither talks about the actual physical requirements. So, how the data gets stored. So, whether it gets stored in bytes, bits. So, how does it actually interact with your hardware. So, it does not talk about it. It only talks about the implementation. So, it essentially transforms the conceptual design into the implementation design. Once you have your implementation ready, the next thing is the schema refinement, because now that as we discussed in the previous session, schema is the description of the data. So, what is the record structure, what are the data types, what are the relationships, operations, constraints, etc. So, now that you have your logical database design ready with all the schemas defined, the next step is to refine it, because the initial design may not give you the complete picture without any kind of inconsistencies. So, obviously, you need to look at if there are any redundancies. Are we storing the data in multiple places, or are we storing the data in a way that leads to redundancy? Are we storing the data in a way that leads to any kind of inconsistency? So, those things have to be analyzed, and we need to focus on removing those redundancies. So, it basically, if you have data stored in multiple times, it leads to a kind of data anomaly. So, you will discuss all those things in the subsequent sessions as part of your course, but the main purpose of schema refinement is to remove all such anomalies. We have insert anomalies, update anomalies, delete anomalies. So, obviously, you should not get into those kinds of anomalies, because the moment you have any kind of data inconsistency, it may lead to the complete failure of your application as well. So, it should be done so carefully. Again, so there may be cases where you have to store your data in multiple places. So, in those cases, you need to consider the situation. So, you need to consider those things into account, and then accordingly you need to design your database. Schema refinement is again an important step to follow, because you need to make sure that you are not compromising on your database performance. You may store it at only one place, but that may reduce your database performance. So, you need to consider those things also into account, and accordingly you need to perform your schema refinement. This is generally done using normalization. You have different kinds of normal forms. So, that anyways we will discuss in the subsequent parts of this particular course. So, you have different kinds of normal forms available. So, this is what we do, and sometimes we may have to do this using denormalization also. So, this is the next step. Then this is the next step in your database design, the physical database design. So, physical database design is the translation of your logical design, because now that you have implemented your database, so you need to make sure that you specify all the essentials that talk about how the data gets stored on your physical media, on your storage devices. So, it focuses on specifying internal storage structures. So, how the database files are stored on your storage device, and how the files are organized, database files, and what kind of indexes you need to create, because indexes are part of your performance management. So, and how the data gets accessed. So, access paths, for example, you are querying the employee details. So, how does it get accessed from your database? So, what is the path that it has to follow? So, you have different kinds of optimization techniques that we discuss in performance management, cost based optimizers and rule based optimizers. So, all those things, and what are the physical design parameters, how much heap space has to be there, how much cache has to be allocated. So, all those things have to be specified in your database files, so as not to tamper with your database performance. So, this is physical database design is mostly done by your database administrator. As a developer or a designer, you do not consider these things into account. Your main focus is on coming up with conceptual design, logical design, and schema refinement. Physical database design is generally done by database administrator, because they interact more with the hardware. So, they consider all those aspects into account. So, the initialization parameters, the database initialization parameters, where are the files stored and how are those files organized. So, all those things are specified, and how frequently should we archive the data, how frequently should we take backups of the data. So, all those things are addressed in your physical database design. So, it also analyzes the database workload. If there are too many users accessing and too many activities are going on, so they need to refine this physical design. So, physical design is again is not a one-time activity, it keeps performed. So, database administrators regularly check the database workload. So, automatic workload repository reports. So, they generate those reports. Based on those reports, they will refine the physical database design. So, they increase the number of operating system processes or reduce the operating system processes, or they allocate more memory to them. So, all those things are performed. So, basically the main purpose of this activity is to meet the performance criteria, because while during the function requirement analysis you specify both functional and non-functional requirements. Performance being a non-functional requirement is addressed here. So, and they also look at the scalability, portability. So, all those non-functional requirements are addressed in your physical database design. So, the last step, but the most important step, one of the most important activities in today's application design is the application and database security, because most of these today, if you look at the data, most of the data is sensitive, personally identifiable information. So, if anybody gets access to it, so they can do anything, something like your credit card numbers, debit card numbers, PIN numbers, all those things. So, your payment details, or it may be related to your personal life also. So, this particular step establishes the principles on how to deal with your sensitive data, personally identifiable information. So, it defines the encryption and decryption mechanism, because you do not store the data in plain text. Certain data should not be stored in plain text. Your debit card number or a credit card number should not be stored in plain text. So, you need to encrypt it. So, when you store it, you need to use certain encryption mechanism to store it, so that when you query the data, when you want to see the data, you do not see the plain text, you see the encrypted data. But when you access it, when you are trying to perform a payment, make a payment, So, the encrypted data has to be decrypted. So, the encryption and decryption mechanism is specified. It also specifies authentication and authorization principles. So, what kind of users have access to data? Can anybody access this database? Obviously not, because there are certain people based on their role and designation, they can access only specific part of the data. So, you need to specify authentication. So, they need to authenticate themselves, they need to give their security credentials to get access to their database, and authorization. So, am I able to access this particular data? For example, payment data, only finance department should get access to it, not all the other departments should not get access. Like employee data should be accessible only to HRMS team, a human resources team. Others should not be able to see the data. So, how do you specify those authorization principles? So, you need to specify the user roles and access control lists. So, basically this talks about the definition of your security realm, which consists of authentication, authorization, all those security related aspects. It is an inevitable part in software application design these days. So, you cannot do away with it. So, you have to take into account the application and database security. So, now the first step, assuming that we are done with the requirement analysis, the very first step is to coming up with your conceptual design, because that is what, if you look at the sequence of steps here, we have requirement analysis. Now that we have the requirements ready, all the data requirements are in place, the next step is to coming up with the conceptual design. So, how do you design your database conceptually? So, what are the activities involved in it? So, this includes various data. So, you need to understand what are various data items, how can they be grouped. So, how are they interrelated. So, what are the operations that you need to perform, how to identify individual data elements. So, this step focuses on addressing all those things and coming up with a conceptual schema. As I said, schema is a description of your database. So, this particular thing addresses the conceptual level schema. It is a high level schema, it is a high level description of your database. It does not talk about how the data gets internally stored or how the database gets implemented, because they are part of your logical database design and physical database design. So, the next session focuses on specifying various concepts involved in conceptual design, and conceptual design is done through various modeling techniques, and one of the popular techniques is the entity relationship modeling. Of course, we have object modeling techniques also using unified modeling language, UML modeling, but today's session focuses on ER modeling, entity relationship modeling. So, again, these are the references that you may have to look for more details. So, it is chapter 7 in Fundamentals of Database Systems by El-Masri and Nawate, 6th edition, and you can browse through your online resources also for more details onto it. So, now let us get to the next session, where we talk about entity relationship modeling and conceptual design using entity relationship modeling. So, in the second session, we discussed about the steps that we need to perform in the database design, requirement analysis, conceptual design, logical design, physical design, etc. So, as part of that, the very first post requirement analysis, we start with the conceptual design. So, this session talks about the conceptual design and some important aspects of conceptual design using entity relationship modeling. It gives a brief introduction to entity relationship modeling. So, basically what does it do? The conceptual design. Conceptual design focuses on identifying various data entities, their properties, relationships, and possibly certain constraints. So, this is done using entity relationship modeling. So, it basically this entity relationship model focuses on unleashing the interrelated things in a specific domain of knowledge. As said, database talks about a mini world, like a university, like a student database, or a manufacturing company, or a customer relationship management company. So obviously it's a universe of discourse which talks about only the data related to that particular domain. So this entity relationship model identifies the various elements involved in it and their interrelationships and properties. It is proposed by Peter Chen in 1976. It is popularly expressed using diagrammatic notation, that is called ER diagrams notation. So that also we will discuss in this session. So before we get to the understanding of entity relationship model, let's take an example domain, because an example will make things clear. We can easily map a database the design of database to a conceptual design. So we have a company database which is organized into departments, and each department has certain properties like name, number, etc., and an employee who manages it. And each department may have several locations. And the second thing is, department controls the number of projects, because a department can have multiple projects. Each project has its own properties. And then company consists of several employees. Each employee has certain data elements like social security number, etc., address, salary, etc. And each employee works for one department, and he can work on multiple projects. Each employee may have one or more dependents or zero or more dependents, and dependents have these kinds of attributes, the attributes name, gender, birth date, relationship to the employee. So the reason why we have taken this domain is to understand this model, because this is the requirement we have. After requirement analysis, let's say this is what is given to us. So how do we map it to conceptual design? Just to understand it, we've taken this example. So before we go to the conceptual design for the domain that we have taken, let us look at some of the definitions here. So the first one is an entity. Every data item is called an entity, every component or an object. So an entity is a specific object or thing in the mini world. As I said, the domain that we are creating, the company domain, is a mini world. In that, every entity is a specific object or a thing. For instance, an employee John Smith. John Smith is an employee in the company for which we are designing the database. So he is an entity. And research department research is an entity. Project, product X, for example, somebody is working on product X, so that's a project. So that's an entity. So every noun form can be broadly categorized into an entity. So an entity represents a physical thing. It may have a physical existence or conceptual existence. Physical existence in the sense an employee physically exists, so you can see that. And customer account number, for example, a bank account number, it's a conceptual thing. You cannot touch it. Basically, it's an intangible thing. It's a conceptual existing thing. So the next thing is attributes. What are the attributes? Attributes are the properties to describe an entity. So entity just gives the name of that particular thing. For example, John Smith is an employee, so that's an entity. What does that entity consist of? So what are its properties? So those properties are attributes. For instance, employee John Smith may have certain properties like name. He has a name called John Smith. He has a social security number. If you're talking about the Indian perspective, so he may have a unique identification number, Aadhaar number, address. He may have gender, as male, female, date of birth. So all those things are the attributes of that particular entity. So a specific employee may have these kinds of, for example, as you can see, John Smith is the name of that particular employee. SSN is so and so, his address, his gender, birth date. So each attribute has a data type associated with it. That's another important thing, because conceptually, when we are specifying the conceptual thing, you need to understand what kind of data you are storing. So each attribute has a data type. For example, your name is a character kind of data. Your date of birth is date kind of data. Your social security number is a number, numerical data. Your age is numerical data. Your address is alphanumeric data. So obviously you need to understand. Likewise, your gender, it can be either male, female, or transgender. So you have an enumeration. You have only 3 possible values. So, each attribute has a data type associated with it. So, now that we have understood the entity represents a physical thing, an existing thing, it is a real world thing. So, all such entities, related entities are grouped into an entity type. For example, you have several employees, one such employee is John Smith, another employee is Joe Burns, another employee is Steven Smith, something like that. So, you have 3 or 4 employees or hundreds of employees. So, these are all individual entities. So, you combine them, you group them into an entity type. So, in this case, you may combine all your employees into an entity type called employee. So, it is an entity type. So, it represents an entity type. It is not the physical thing, it is the conceptual thing. Likewise, you may have several projects going on in your company. So, all those projects are grouped into an entity type called project. So, you have several project entities, all those entities are grouped into entity type. So, entity type is the conceptual thing, whereas your entities are the actual data, physically existing things. So, each entity type will have a collection of entities stored in the database as discussed. So, employee entity type has several employee entities, project entity type has several project entities, your department entity type has several department entities. So, your entity type does not change, the entity type along with its attributes does not change, but the entities keep changing. So, because you update, for instance, you may have a new employee joining. So, you add those details. For example, the details of an existing employee is changed, his salary is changed, or he has retired. So, you update the retirement date of retirement, or he has got promotion. So, he is promoted to the next level. So, his designation changes. So, all those things keep changing, but actual entity type does not frequently change unless there is an inevitable requirement to add new attributes to it or modify the existing attributes. So, the actual data, the actual entities stored in your entity type is called entity set. So, that we will discuss in the subsequent slides. The next one is attribute types and attribute. So, each entity has several attributes as we discussed. So, in this case you have several attributes. For example, employee entity has SSN, name, address, etc. So, these attributes, so each attribute has a single atomic value. So, these are called attributes. The properties of your entity are called attributes. They can be categorized into different types. One is simple data type, simple attribute type, which means it consists of only atomic value and non-composite value. You cannot further divide it. For example, SSN cannot be divided, your Aadhaar number cannot be divided into different parts, your gender cannot be divided into different parts, it is an atomic value, you have only a simple value. There may be certain composite attributes, like you can further divide them. Your name may have your first name, last name, middle initial, etc. or address, your address has first line, second line, address line 1, address line 2, city, state, postal code, pin code. So, all those things, country name, etc. So, it is a decomposable attribute. So, such attributes are called composite attributes, and there are multi-valued attributes. So, an attribute may have multiple values. For example, you have an entity called car. So, car is available in different colors. So, color is a multi-valued attribute. So, degrees of a student can possess multiple degrees. So, that is a multi-valued attribute. Likewise, customer account numbers. A customer can have multiple bank account numbers because he may have different bank accounts, accounts with different banks. So, obviously, customer account numbers is a multi-valued attribute. So, an attribute of an entity type, and the next thing is the key attribute. So, what do you mean by key attributes? So, you have entity type consists of several entities. So, how do you identify each entity uniquely? For example, I want to find out the details of a particular employee in employee entity type. How can I identify that? So, to identify a particular entity, you may define an attribute with certain unique value. So, that attribute is called key attribute. For example, your Aadhaar number or employee ID can be used to uniquely identify a particular employee, or student roll number. Roll number itself can be used to uniquely identify a student. So, that the attribute which can be used to uniquely identify an entity is called the key attributes. The reason why we are discussing these dimensions, these definitions is to understand the ER modeling. So, now that we have understood the entities, the attributes of entities, what are different kinds of attribute types, what is an entity type and what is a key attribute. So, how do we diagrammatically represent these entities? So, this is another thing, because as discussed earlier, ER modeling is not a descriptive one, it is a diagrammatic representation. So, how do you describe your entities and attributes diagrammatically? So, an entity type is generally displayed in a rectangular box. So, there are different notations, but the notation that we are following is the one which is proposed by Peter Chen in 1976. So, we are following the same thing here. So, rectangular box, your entity type is represented in a rectangular box and attributes are displayed in ovals. So, each attribute is connected via a line. So, components of composite attribute are connected to multiple ovals. For example, your address has address line 1, 2, zip code, etc. So, again multiple ovals are created and they are connected to the address attributes. So, multi-valued attributes are displayed in double ovals. So, 2 overlapping ovals, and each k attribute is underlined just to indicate that this particular attribute can be used to uniquely identify an entity. So, let us look at the company database entity diagram. So, we have identified, the very first step is to identify entities. In any database design, the very first step is to identify the entities. In your company data domain, you have an employee, you have a project, you have department, you have a dependent, because these are the noun forms that we have looked at. Maybe you can further refine it, but at this moment at a high level, this is what we can understand. So, department has a name, so that is represented in oval, and department has a number, department has a manager, department has a manager start date, because manager keeps changing. So, obviously, when is the new manager appointed? So, his joining date or starting date is also important for us. It is an important data requirement. Assuming it is an important data requirement, we have put it as an attribute. And locations, we know that department can exist in multiple locations. So, obviously, it is represented using 2 ovals or double line oval. Likewise, you have project. Project has a name, number, controlling department. You have a location. Project exists in only one location. It is not executed in multiple locations. That is why it is a single valued attribute here. And you have employee. As you can see, employee has several attributes. Employee name is a composite attribute. That is why it is further refined. It is further divided into F name, nothing but first name, middle initial and last name. So, it says that name is not a simple attribute, but it is a composite attribute. Employee is always associated with a single department, because that is what we have specified in our requirement specification, and he has birth date, salary and etc. and works on. Employee can work on multiple projects. That is why it is a multi-valued attribute, and this is a composite attribute as well. So, works on project and he works on, because assuming he works 9 hours a day. So, 6 hours for one project, 3 hours for another project. So, that is why it is a composite attribute. Likewise, dependent is also another entity. So, does it suffice to actually represent the entire domain? So, entities alone do not represent the complete database conceptually. So, because you have not specified the relationships, because specifying entities will not give you the complete picture. So, how are they related? Because we know that employee is working in a department, employee works on a project, so employee has dependents. So, where are those relationships specified? Without specifying those relationships, there is no meaning for your data requirements, because if you look at your actual requirement description, so it is specifically specified that essentially each employee works for only one department. That's the key thing here. So, where is that relationship specified? But he may work on multiple projects. So, where is that relationship? So, that is also an important part to be specified in your conceptual design. So, entities, they represent only some part of your database, but they do not represent the complete details of your database. So, we need to specify how those entities are related. So, entity relationships are specified using relationships. So, that is why it is called an entity relationship model. It is not just an entity model, but entity relationship model. So, what do you mean by a relationship? A relationship relates two or more distinct entities. It does not talk about the entity types, it talks about the entities. So, two or more distinct entities with specific meaning. So, because that relationship has some kind of a meaning, it has to be meaningful. So, for instance, employee John Smith works on product X project. Employee John Smith works in research department. So, these are important relationships. So, there is a relationship between employee John Smith and department research. There is a relationship between employee John Smith and project product X. So, how do you specify those relationships? Relationships of the same type are grouped into a relationship type. So, now that we have understood the relationship exists between two entities. It does not exist on entity types. It does not exist between entity types. It exists only between two entities. As I said, John Smith works on product X. So, obviously, John Smith is related to product X project. He is not related to any other project. He is related to research department. So, there is a relationship between John Smith and research department. There is no other relationship between other departments and John Smith. So, relationships of the same type, like there may be multiple employees working on multiple projects. There may be multiple employees working for multiple departments. So, all such relationships of the same type are grouped into or specified into a relationship type. Just like multiple entities are grouped into an entity type, multiple relationships of the same type are grouped into a relationship type. For example, works on relationship. So, employee John Smith works on product X. Likewise, employee Stephen Smith works on product Y. Likewise, employee Joe Burns works on product Z. So, these are all related. These are all of the same type because employee working on a project. So, obviously, you can group all such relationships into a relationship type. In this case, you can define a new relationship type called works on, which exists between employee entity type and project entity type. So, you need to distinguish between entity type and entity. That is essential part in your entity relationship diagram. So, the next thing is, how do we specify the degree of a relationship? What do you mean by a degree of relationship? As if you look at the definition of a relationship can exist between two or more entities. So, how many entities are participating? So, if you talk about the relationship type, how many entity types are participating? If it is 2, for instance, employee entity type is related to project entity type via works on. So, there are only 2 entity types, employee and project. So, that is why it is a binary relationship, but there may be cases where multiple entity types participating into one relationship. So, in that case, the degree of the relationship changes. For example, if you have 3 different entity types participating in a relationship type, then or connected through a relationship type, the degree of that relationship type is 3. So, you can extend it, but generally we deal with binary relationship. Even though we have relationship types of higher degree, we will try to decompose them into binary relationship, because expressing relationship types is easier with binary relationships. So, relationship types and relationship sets. So, relationships of the same type are grouped into a relationship type, as we have already seen the previous slide. In this case, works on relationship type is a connection or the relation between your employee entity type and project entity type. So, it is the schema description. Basically, entity is the schema description of the real world thing, and relationship type is the schema description of your relationship. It has a relationship name and participating entity types. At the same time, relationship type may also have certain attributes. Relationship type also may have certain attributes. So, we must consider those things also into account and specify. So, relationships maintained in a relationship type, as I said, entity is the physical thing, entity type is the conceptual thing, and the list of entities stored in a relationship type is called an entity set. Similarly, relationship is the physical thing, it exists between 2 entities. Relationship type is the conceptual thing which exists between between two or more different entity types, and relationship set is the actual list of relationships stored in the relationship type. It represents the current state of your relationship type. So, how do we specify the diagrammatic notation of relationship type? Relationship types are specified using a diamond shaped box, and the entity types participating in that relationship type are connected through single lines via straight lines. So, this is your ER diagram. As you can see, employee works for department, and employee manages a department, employee works on projects. So, employee has a lot of dependents. An employee can have a supervisor. Supervisor is also another employee. So, this is the entity relationship diagram. At the same time, we also specify the cardinality. Cardinality is nothing but how many entities can participate in relationship type. For example, n employees can work for one department. So, any number of research department, it does not consist of only one employee, it may have several employees. That is why n employees can work for one particular department, and each employee can participate on multiple projects. So, and a project can have multiple employees. So, obviously, this is m is to n. So, this is similar to your functions. So, m is to the functional relationships in functions. So, that is a brief description of your company database. It is a conceptual diagrammatic notation of your company database. So, from here on we need to still extend. So, what are different types of relationships, and how do we specify the cardinality, the relationships of higher degree, how do we specify? So, what are different types of entities, weak entities? So, all those things we will discuss in the subsequent session. So, this gives you a brief introduction to ER modeling, and then we will further extend it to other types of ER models like extended ER model and alternate notations for ER model. So, again you can go through the chapter 7 in the fundamentals of database by Elmastri and Navate for more details on this session. Thank you.